Geothermal energy. How geothermal energy works. Below the surface of the Earth, there is a largely untapped reservoir of energy in the form of heat, called geothermal energy. Underneath the Earth's crust, radioactive materials emit energy via radioactive decay, heating a layer of rock and molten lava. For the purpose of geothermal energy production, areas known as hotspots have been located at various locations. These hotspots are typically found at tectonic plate boundaries where the Earth's crust is thinner. This allows magma to flow closer to the surface of the Earth. Geothermal energy is renewable in the sense that the heat generated from this radioactive decay will be sustained for the foreseeable future. How a plant works. Geothermal plants work by drilling a well called an injection to channel out geothermal fluids into the plant. The fluid is pressurized, then allowed to expand, turning a turbine and generating energy. Energy from the turbine is sent to the transformer and utilized. The west coast of Canada is situated on the Ring of Fire, also known as the Pacific Ring of Fire, an underground network of volcanoes with an enormous potential for this geothermal energy.
There are several types of geothermal power plants. Each of them converts heat to electrical energy but using different methods. Dry steam power plants extract the hot steam from below the crust and is fed directly into the turbine. The steam is then injected back into the reservoir and then reheated naturally. Another method is flash steam power plants, where the hot water is pumped out of the reservoir, which is then converted to high pressure steam. When it cools, it is injected back into the reservoir. Another method is a binary cycle power plant, where a second fluid is used to lower the boiling point of the liquid heated, then the vapor is produced faster, in such a way it is then injected into the turbine and then generates electricity. This liquid can be pumped back into the reservoir, and this method requires a higher maintenance cost than the other methods.
Impact on the oil and gas industry. Energy production in Canada is dominated by sources like hydro, uranium, and natural gas. The oil and gas industry is the one which would be most impacted by the inroads made by geothermal sources due to the push for sustainability. This could take effect in the heating of buildings, which can be provided by direct use of geothermal energy instead of the homes primarily in Western Canada, which have their energy needs met by natural gas. These techniques can be implemented through the work of civil, mining, geological, mechanical, and geothermal engineers. These engineers would collaborate with geologists and environmental scientists. However, the geothermal energy sector does not have the system in place to compete at a reasonable scale. In addition, the vast majority of the oil and gas production in Canada goes towards consumption by vehicles as fuel. This part of the industry cannot be replaced by geothermal energy due to the hydrocarbon requirements of our society's transport methods. Thus, it is unrealistic to expect geothermal energy to have a big impact on the oil and gas industry in the short to medium term.
Geothermal springs are located around current or ex-volcanic places, and usually speaking around remote areas still impregnated with wildness. Those places are typically where First Nations were pushed to and where other energy sources are difficult to reach. Geothermal energy is an ideal opportunity for them to use renewable energy easily without depending on anyone else. So far, they were indeed dependent on petroleum and natural gas delivery, which was very polluting and expensive. On the one hand, this destroys their environment and kills their way of life, since they require harmony between themselves and nature. On the other hand, access to energy was also a form of pressure imposed on them because of its costs and the necessity to be constantly in place. They may work with oil companies without social protections. However, plants require a huge place to be built, leading to deforestation and a potential move of people's household. Also, the vapor released may contain natural toxic particles such as boron, antimony, or arsenic. This is notable risk both for the environment and health because it may precipitate in farmlands and spring water.
Environmental and health impact. Implanting geothermal has many advantages such as reducing CO2 emission, it is renewable and a stable source of energy. However, there is also environmental downsides in using this type of energy resource. The drilling process to access the water below the surface of the earth has the potential of releasing gaseous emissions such as carbon dioxide and hydrogen sulfide. The drilling as well leads to an increase in seismic activity. Finally, the construction process of geothermal plant can disrupt natural habitats and alter wildlife and vegetation. It reduces species diversity. Engineers must work collaboratively with people in non-engineering fields to ensure the environmental aspect of the project. The collaboration with environmental scientists, foresters, and environmental engineers is crucial to protect the environment and human health.